All right. All right. Shamar, Georgian, Rochelle, Krishana, Shavanis, Kai, um, Kyle, these names, boy, these names. But it have a certain name that I want to call out specifically today before we start. Though. Is this my name, boy? Um, this is my name, boy. I'll just know. I had to find this name. We starting now. You see this name here, boy? He getting a special shout out today. Bring up the board day that we shout out this man. The man name is Ghosty Pun. Ghosty Pun, I want to take a look at that. I want to take a look at that score there and tell me what you see. Ghosty Pun, you there, boy? I remember Ghosty Pun was getting me talks yesterday and saying that we're going to lose this match and thing. Ghosty Pun, have a nice day. All right, let me jump into it. So today we're going to do statistics. That's the question 5. Today's the 5th day we're doing this, and it's been a spectacular week. I am very tired. Not really from this, from other things. And I have AdMaths class in a little bit, so AdMaths students gears up. I have my AdMaths lessons class. But the maths must go on. So we are going to do statistics today. Statistics, it usually comes in number 5. It's one of those topics that isn't really tested in section 2 that much. You don't really see any statistical stuff show up in section 2 of the maths paper. It can, however, swing in the paper 3, so private candidates be ready for that. So this question here. This question here is about cumulative frequency, and it's by far the most popular thing tested in statistics, and it's like the hardest thing or the most comprehensive thing, cumulative frequency curves. But what can also be tested? Let me see if I can get a blank page 3. A blank page 3. What can also be tested is different graphs now, boy. So of course there's the pie charts, which have been popular these last few exams. Pie charts has been popular. Then there is histograms, and there are histograms, and there is why am I sticking to remember these things? I'm just histograms and bar charts, and we have frequency polygon, and it's now coming back, and line graphs. And then we have the big boy, cumulative frequency curve. So what you should know is the difference between a histogram and a bar chart, the difference between a frequency polygon and a line graph. The histogram is a cousin to the frequency polygon, the bar chart is a cousin to the line graph, and the histogram and bar chart in the same family, and the frequency polygon and the line graphs in the same family, same vibe kind of thing. And pie chart see by itself there. And of course, all of this, you would get a question on probability in the ending. A simple question. Probability for CX is not a big thing. Probability, and you could get, the quartiles and group data versus on-group data stuff. Different measures of the statistical average, statistical mean, mode, median. You could be asked to explain standard deviation, SD standard deviation. So we have a bunch of different things that they could push you at with statistics. So if you want to see some stuff on statistics, just look up Cohen Springer Statistics online. This is a reminder to everyone here to press the like button, and that we're going to have a massive crash course, not this Saturday, not tomorrow, the following Saturday from 12 to 12 in the day to 12 in the night. And of course, you know the drill. You WhatsApp this number to join the crash course, the number that's showing up below here, the screen. You WhatsApp that number and you would talk to the admin and tell them, hey, I want to join that crash course. So hold in and jump in. All right, so good evening to everybody. Ariel, let me just jump into the question now. So what we seeing here? This is the weight, this is the cumulative frequency. Distribution of weight of 80 there, thereby recorded by a zookeeper. Which zoo have 80 days in it, by? There's really be making up some weird things for this maths thing called maths. What going on these days? They're now born? Oh, this was so light. And then again, more and more now the cumulative frequency. And it's 80 days and all, and then you have and then you need to determine the upper class boundary for 21 to 40, class 21 to 40. So the upper class boundary for the UCB, 21 to 40. Well, the upper class boundary for class 21 to 40 is not 40. That's the limit. That's the upper class limit. The upper class boundary is between 40 and 41. So the upper class boundary is 40 plus 41 divided by 2. It's 40.5. And you can't just write that alone. Oh gosh. You have some kind of something about yourself now. Kilograms, man. Kilograms. 40.5 kilograms. Determine the class width. So what's the class width? How you find class width? Class width. Find the class width. You take out a tape and measure the width of the class. No, you don't. Of course, you don't. It's the upper class boundary minus the lower class boundary of any class. The class you're interested in. So it'll be 60.5 minus 40.5. Agreed? Because the lower class boundary of the 41 is lower class boundary for 41 is 40.5 and the upper class boundary is 60.5. Why is in the chat if you understand what I'm reading here? So you don't subtract the limits. You don't say 60 minus 41. You actually say 60.5 minus 40.5. And with that, you get a nice, beautiful 20 kg. So adjust a little per kg. And a little per kg again, man. So you're going to leave them thing out for the exam. No units in the exam. How many there were recorded in the class 81 to 100? All right. So, well, the cumulative frequency left off at 36 there. In the previous class, how much we had? We had 36 there. And at the end of this class, at the end of class 81 to 100, all of a sudden, we had, how much we had? So previous class, we had 36, and this class reached 58 there. 58 there. Theirs is plural. What is plural are there? Theirs? Or you just right there? I don't know. So now this is not English class. I feel it as theirs. So then, and therefore, class 81 to 100 will have to be its cumulative frequency. So you subtract. If your screen blurry, you need to go on the settings, the gearbox, and raise your resolution, raise your quality. All you're supposed to be of a generation where you're supposed to be able to figure out those things. That come on, man. 58 minus what it is 36. 58 minus 36 now. So yeah, 36 here. Yeah, 58 here. 58 minus 36 is how much? How much are they get? 22 there. Oh, good. Are they paying the units now? Hey, look at all you. Look at all you put in the units and thing now. Well done. So now I'll get your marks in the exam for units. A day was chosen at random. I know them going to make me make a cumulative frequency at what I get away. But anyhow, these statistics class are going to inevitably have to draw a couple graphs and thing. Maybe some pie chart and thing might come into this. Saying that, see if you see the protractor across there. Because I smelling that pie chart from a mile away. Hey, you need that protractor to draw the pie chart. Eh? Those are you like to go in the exam without thank you. Without geometry set, you need that protractor to draw pie chart. Number 4, too much talk. Let me see if we can get number 4 all the way fast. Number 4 on sheet 4. Yeah, number 4 on sheet 4. So a day was chosen at random from the 80 day. What was the probability that the weight of the day is more than 105? Leave your answer in exact value. So what is the probability that is more than 105? Okay, let me go back and see where 105 stop off. They say 105 or 100.5. I just reading things, 100.5. So where 100.5 stop off? Let me go back to slide 1 and see where I really stop off. Slide 2, that is, I mean. Slide 2. 105 is here. So that's after this. So what's the probability? It stop off at 58. 58. 58 people. 58 days, not there, or whatever is the plural of day. So 58 day under 105. Okay, 58 day under it. So what's the question? I go back to the question. There was chosen at random from the 80 day. What is the probability that the weight is more? So probability is the number of desired outcomes over the total number of outcomes. And the desired outcome is 58 there. No, it's not. That's 50 there under. It's 80 there now. So the desired outcome is that there are 80 minus 58 there that are over 100.5. And then if you could just snap Christy Sarah thing onto the bottom of the screen for a little bit. And then we divide this by the total number of outcomes, which is 80. Link my calculator too, but don't show the calculator like that. How much I get when you do this? They didn't ask you for mean. They asked me probabilities. What are you doing right now? You jumping the gun. Thanks. So 22 over 80, which could break down to what? 11 over 40. So I refuse to just think about that a little bit. The median weight was calculated to be 70.5, that's the middle. Is this calculation correct? Justify your answer completely. So let's go back and use our expert decoding skills to see if that's sounding medianish. Let's go back to examine this, this so-called cumulative frequency table curve thing. Wait. I want to just get the table by itself earlier, and I'll put it on a fresh new slide because I feel like I need to see it big and it's small. So let me go on to slide 5 and slide 5. Yeah. And we'll put that there, like the table, and we'll look for the median. So they say that the median is found, the median is 70.5, right? So this suggesting that the median is equal to 70.5 kg. Now, can that be the middle? Can that be the middle weight? Now, what's the middle? The middle, you can just watch this and see. The middle term, or Q2, is found by saying n plus 1 divided by 2. So it's really 80 plus 1 divided by 2, which is 40.5 term. So this is where you'll find the median. All you understand what we're talking about when we say Q2, Q1, all them kind of thing? No, that's something that some students bounce up to right before exam and like, what in the world is that? When they bounce up to it, like they have no idea that this existed. So let me just give you a quick little, so you feel a little comfortable about it now. Let me add on our next slide again. This question taking real slides, 6, and let me see what's going on, right? So let me say I give you a bunch of data. I'll you pay attention again. You the mini crash course on these quartiles thing. Let's say I give you a bunch of data, right? And I see one is 6, one is 7, one is a 7 again, one is 8, one is 13. I want to go in order. One is 15, 1, 2, 3, median, one is 17, one is 20 or something like that. 1, 2, 3, 4, 5, 6, 7, 8. I want to make it 9. Let's say it's 21. Okay. What's the middle value here? Are you seeing the 21 or my blocking? Are you seeing it? That is estimation good day. So what's the middle? What's the middle? The middle value. What is Q1, Q2, and Q3 and thing really stands for is, and Q4. This really stands for if we divide the data into 4 parts. Like if you divide the data into 4 parts. So the middle value, you all remember to do this cross, circle that you did. 13. But what we're saying, watch what we're saying, what we're saying is that the middle value can be found using this formula. We could call it Q2. That's the middle, right? And this Q2, again, a little more explanation just now. By adding up how many values we have, 1, 2, 3, 4, 5, 6, 7, 8, 9, and say 9 plus 1 divided by 2. So it's 10 divided by 2. It's on the 5th term. You're seeing it now? You're seeing it now? This is the 5th term. The middle value is found at the 5th term. This formula works. Now, why we adding 1? Because if you don't add 1, you'll just end up dividing the thing by 2. You wouldn't find the middle. Finding the middle of a set of items is different than dividing by 2, you know. Let me show you what I mean. Let's think about this. Like if I say 2, 4, 6, what's the middle? What's the middle number? The middle number is 4. But if I say divide the number of items we have here by 2, you know where you're going to get? This is 1, 2, 3 items. 3 divided by 2 is 1.5. But the middle term is not 1.5 is here. That's between these two. So you catch why we need to add the 1 in the formula. Somebody probably never know why we add in 1 all the time. It's just how these things set up. Finding the middle is not the same as dividing by half. So the middle term is there. You see, the step further we're going to take is find the middle of the middle. The middle of the middle. You'll see it a little better if I don't put 9 terms. Like if I put 11 terms, you'll see it a little better. So let me put in 2 more terms here. Are they wait with 10, 11. I don't want to get fractions in the example. 24 and 30, right? So what's the middle term now? What's the middle term now? I'll hurry up because this is not supposed to last so long. What's the middle term now? If it's even numbers, don't worry about it, Jonathan. Just follow these formulas still. You will still get, you'll get a decimal, but don't worry about it. Just find, I'll show you what to do. So the middle term is actually 15. And if you cross, or if you say 11 plus 1 divided by 2, you still get the 6th term. 6 is not the answer. 6 is where the middle term resides. It resides on the 6th term. That's very important to understand that little discrepancy there. So, and now, so this is Q2. But if we divide this and we find the middle of the top half and then the middle of the bottom half, we'll realize that this is Q2, right? Q2 is n plus 1 divided by 2, halfway through all the items. Q1 is a quarter way of the n plus 1, or n plus 1 divided by 4. So which is same 11 plus 1 divided by 4. It's found in the 3rd term. So you see that Q1 is over here. Class, ladies and gentlemen, Q1 is that guy. It's like if you found this remaining items here, exclude Q2. You found and you cross. It's the median of the lower half of the data. So because it's actually splitting the data into 4 parts, we call it quartile. This is the first quartile. That is the name out. This is the name in the this is his name on his birth certificate. First quartile. But we call it Q1 outer road. Q2 is called the second quartile. That's the name on the birth certificate, but we call it the median, right? We call this the median, the middle. And then Q3 is work it out. Q3 is this one. And the formula for Q3 is 3/4 way of the data, n plus 1. Oh, Oh, so now you know. Now you know. That's a quick little look into it, but you still need to practice it. You might feel like you know everything now, but you still need to practice it to get the little rough edges. So the question was asking us, let's go back to slide 4. The question was telling us that they work out the median and they get it to be 70.5, and I want to know if that calculation is correct. Well, if we go to slide 5, we would see that the median is found on the 40.5 term, right about this, right? The upper class boundary of this guy, 40.5. No, sorry, this is 40.5 term. Where is that? That's somewhere between this and that. Somewhere between here and there. You understand what I'm saying? This is the number of items going on. We have 80 items. By the time we reach here, we have 15. By the time we reach here, we have 36 items. I need to reach to the 40.5 item, the 40th term. And that's somewhere inside here, bro. That's where that will come. So that means the median can be found in which class interval? Is found in the 81 to 100 class interval. Therefore, 70.5 kilograms cannot be the median. How would that be the 70.5 inside here? The median would be a number between 81 to 100, and I saw you call that. So they asked us really recently, they asked us like about 2-3 years ago, and they keep asking this every 4 or 5 years to look out. This question taking real long to finish by Joseph. On a sheet, and now I need to go and construct a community frequency code using the information provided. Ensure to label your axis. That is a whole set of marks. But this is not the way question 5 comes right now. It's only come for 9 marks, but they could still ask you to draw the curve. Use the community frequency curve to estimate the upper quartile. So I want to take this table on page 5 and draw a cumulative frequency curve. So I want to copy back the table. Let me see if I can do that. I want to copy back the table. Yet another slide I'll stick in by 6 there. And see if you can find a background that have a graph on it. Is that one? And right, graph paper. And now I'll put this here. I just want to give you all an idea of how it works, how to construct it. This is not how the CSEC graph paper looks, so that's a little unfortunate, but we can still fight it. The CSEC graph paper has like 5 and 10. It's like a block of 5 and then a block of 10. So, but you'll catch the idea. So we want it to go up to 80. So this is on this side, on the y-axis side. And I want to try again with the ruler, the long ruler. So the y-axis needs to go up to 60, and the x-axis needs to go up to how much? 140. So I divide my stuff accordingly, and I'll see. So somehow when I draw the ruler digitally, it still come out bend. I don't know what is that. So, oh, this time it come on straight. And then I'll just stay by and watch me do this. If I take enough time to do this, I'll leave this video in. And then, okay, so let me see. 10, 20, 30, 40, 50, 60, 70, 80, 100, 90, wait, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Can I make 140? I really want to make 140. So what I'm going to do, pull this back like this, and hopefully what I'm about to try here would work. I'm about to try a little movering. Let's make this smaller, and I'll select this and move it. The stress is alive on this boy. Where is move that way. You come back. Yeah. Yeah. All you see now there? Nice. So now I didn't want to double up. All you can do them thing, all you can move the graph and you can try it on your paper and thing when you draw the graph, see if you could pinch zoom it and thing now. So 10, 20, 30. So make sure you plan ahead. 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, and 140. We looking good? So you write your thing one time. This is your weight in kg, and this is your cumulative frequency here. You write out fully cumulative frequency, then you write number of days or something. You just want to have a label for everything. And this needs to go all the way up to 80. I feel I could do the same 10, 20 thing. 10, 20, 30, 40, 50, 60, 70, 80. So what you'll do here is write your scale. And you write like 1 centimeter is equal to, in this case, Larry, suppose this was 1 centimeter. So 1 centimeter is equal to 10 kg, and you put x axis. Y is in the chat if you understand how you do the scale. And then you put y axis, same thing, 1 centimeter equal 10 days. So that's how you secure the bag. That's how you secure the bag. All these little tricks and things showing on here. So what's the next thing I'm missing for this graph? So the scale usually goes up top there, but I'm putting it a little on this side here because I feel like my graph might end up in that zone. Oh no, it could be actually. It could be. The next thing you usually put is the title. So you have a little title. Don't write title, right? Some people let's be taking 4 minutes something to figure out what to write to the title. Just write graph of cumulative frequency versus weight. And you're right, you spell out those words. Graph of this versus that. That's what you do for everything. Physics, maths, add maths. Anytime you need to get the title of a graph. Don't overthink it now, man. 10, 20, 30, 40, 50, parallel 0, 60, 70, 80. So far, so good. So far, so good. And then time to plot. Time to plot real cumulative frequency. Now, when you're plotting cumulative frequency, you don't plot not 20. You actually need to plot the upper class boundary. So you're plotting 20.5. So it's actually 20.5 too. So 20 is here. 20.5 will be a little smooth enough. So it's kind of, you see it in the graph here, and make it look like it's going right a little bit off. Some teachers just make you put 10.5, 20.5 here. I'm not about our life. I find that kind of clumsy. I would just move the point a little bit. And 2 is like real low down. So the first point is, for all intents and purposes, we can put him like about this so now, yeah. About this so. Yeah. And 40.5, you understand what I'm doing, right? Is 40.5 and 60, and 60.5 and 15. So I'll already do the 20.5 and 2. It's hard for me to write a point on this. 40.5 and 6. Why these things are to be scraping the bottom of the barrel, so boy. 40.5 and 6. So that usually happens in a cumulative frequency. It starts off slow and then all of a sudden it scoot up like this. What can you guys see? 60.5, 15. 15 done starting to 60.5 done starting to feel like you want to, you know, experiment. 1x. Help me. Oh, 80.5, 36. 80.5, 36. 80.5, 36. There we go. There we get a big expansion. 80.5, 36, somewhere around there. So, what was that? 100.5, 58. 100.5. Oh, that 80.5 in the wrong spot. Are you see now? Fortunately, I could just select it and drag it across. So, come across so there, bro. Like that. Bang. And then 100.5, 36. 100.5, 58. I write this exam in 2005, and I really do not need to be doing this And then 120.573. 120.573 must be around this. So, and then you had to finish off strong. Turn off my pen, turn off. How long this battery looking to die? But it didn't die yet. Every time you come in this class, you must pray this man battery don't die. So far going strong. And then 80, 140.5. And then you connect. How are you looking? It's actually looking pretty good on my screen, eh? How do you find that looking, eh? Looking pretty good. So then we are to do so. But it can't be so. It can't be so shaky. It need to be smooth, but it's kind of hard to do on an iPad. And that is you there. Graph of thing against thing, blah 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 blah. Everything look like V.Re's properties. And they wanted you to use the graph to figure out estimate the upper quartile. This is what you'll do to estimate the upper quartile. To estimate the upper quartile, you go back to the graph and you do the same thing. Q3, remember the formula I gave you is 3/4 of n plus 1. That's the upper quartile. 3/4 of n plus 1, 3/4 of 81, 80 plus 1. At the end of the day, you know, it's some kind of 60.75 something. So what you're going to do is take your ruler and come across from the 60, just a little above 60 because it's like 60.5. Do your little dashes thing. Touch the grass. Hold on. I didn't ship in this just now. Let me make sure. The estimate the upper quartile. Yeah, 60.5. On the cumulative frequency, that is. And then you come back down here like this on the, once you touch the graph, you're bringing back down. Bang, you could even put a little arrow if you want. And you read off that, how it looking? Nah, boy, all you can say 100.5. That looking like 97. So the upper quartile. Therefore, Q3 is equal to 97 kg. Now, hold up. You see all right this here? I should put equal to the 60.75 or something like that too. Did I put 80.1? Sorry, my bad. It should be 81. And this is the 60.752. And then you put Q on like this. 120 was wrong. I fed up now. If all you want to see the accurate diagram for cumulative frequency, go and switch up Cohen Spring and cumulative frequency. But to be honest, 120, my 120 or 120.5 in the wrong spot. He correct. Oh boy. I'm gonna just sort that out for the perfectionists and them. Oh, I'm missing it so by it's just how I had to zoom in. Let me zoom in. I'm so sad about missing this. Both of these wrong. So what we're saying is this man plot the wrong graph here, boy. So it was 100.558. 100.558 drawing it. 100.558 is about here, so 120.573. 120.573. It's about there. So check that now. So what happened is that I'll see my whole screen, but I not seen my whole screen. So I started watching the axis and then follow it back up. So sometimes I get lost when I'm doing that. Like I'll fall into the next line now, boy. So this was 80 point. The next one was 80.536. 80.536. Like this. So let me just accurate this graph a little more. Fix the accuracy on this graph. It will actually change my answer for this for this thing here. The 60.5 would come out like this. 60.75, touch the streets today and come down like this. So the person who say 100 and about 105, that was actually correct. It's like 103. All right. So what is that one? You can't get fed up. So you put it that so you think you communicate frequencies, right? Yeah. This is not a question, it's a quest. So let me just state over what was the issue so that everybody will be clear about it. Let's see if I can get a highlighter here. The issue is that the cumulative frequency doesn't plot with the 20 or with the 1 or with the middle. It plots with the upper class boundary. So I need to plot 20.5 on the x-axis with 2. So 20.5 with 2. Then 40.5 with 6. See that? Then 60.5 with whatever it plot with. Then 80.5, then 100.5, then 120.5, then 140.5. And you plot it with the corresponding y value from that class interval that it represents. And you will get this kind of S-looking curve. Rate out of 10 how much you understand this. Just look up Cohen Springer cumulative frequency for a full, nice, in-depth lesson on it, and you'll get to see me drop the graph and thing again. So the next cumulative frequency curve graph I have, I either racing through it or might skip it, right? Because you see it takes some time. All right, new number 5. The bar graph below shows the favorite type of movie by a class of students. Given that twice as many students like action movie and comedy movies, how many like action movies? So how many for the action boy? Can I write with the highlighter? So you need to read off. I love when they bring bar graphs. They like 3 marks. You know? So action movies would have to be 2 times 4, which is 8 students. How come I didn't answer this one yet? Students. So to have a little issue with these kind of questions, sometimes on this, they might have number of students, and these people will put in a little sneaky little brackets here, 100 of students. So you think you could just write 4? This time you had to write 400 or 800. Catch it? So action is twice comedy. So that's why I know it's 8. It really need to go up like this, touch 8, make a little bar and come back down. Using the information found in part A1, complete the bar graph, we did that. You're supposed to use a ruler and thing, and if you had a shade, hatch. Calculate the number of students in the class, total number of students. So what I do is I usually come in with a pencil and just write 4, 8, 7, 6, 5, just to make sure. So 4 plus 8 is 12, plus 7 is 19, plus 6 is 25, plus 5 is 30 students. And what percentage of students, like, I wish this question come for you. I'm praying for this for you, boy. So percentage sci-fi would have to be 5 over 30 multiplied by 100 over 1. If this company like this, it's like freeness of freeness. How much times 6 is going to 100? 12 point something. 100 divided by 6 is 16.6922%. 8 could go into 100, 12 point something. So what percentage of students is that? And we good to go there. A class. Soon as you see question 5 in the exam, and when it is on the 17th, that is right around the corner in the next 10 days or whatever. Soon as you see question 5 in your paper, scan it through and see if you see draw. If you see draw, set aside some time to draw either cumulative frequency, histogram, whatever it says you had a draw. So don't waste no time. Because you see how time consuming sometimes it is to draw something could take, right? A class of 35 students did an exam that consisted of 5 questions. The diagram below shows a frequency polygon. So you notice how they didn't close up the frequency polygon. Sometimes in CXC, they insist that you must close the frequency polygon, and then when they give you a question, they may close the frequency polygon. So that frequency what is that? That frequency something. It make a polygon, but it didn't really close up to form into a polygon, right? However, we're not fighting it. Completely following table using the information in the diagram. Oh, something's missing here and there. Let's go get it. Let's go get it. So 2 needs to map to 6. Number of correct questions. I don't know if you've seen it. It's a little kind of zoomed out. Let me get a little zoom in there. So you see number of correct questions and number of students. Nice. So therefore, the 2 here maps off with the 6 there. Nice. The 4 actually maps off with the 12. And the 5 maps with the 6 again. Well, they do that. What is the modal number of correct questions obtained by the class? So modal means most frequent. So the modal number of correct questions is what? The modal number of correct questions is not 2, although seen as number most repeated because that's number of students. The modal number of correct questions is not 12, although seen that is the highest frequency. The frequency is not the answer unless you specify what's the highest frequency, the modal frequency. The frequency is not the answer. This just indicates which one is the answer. So the modal number of correct questions is 4, right? 4 is the answer. Let me don't put an exclamation mark there. 4 factorial means something else. So the modal number of correct questions is 4. If you're not seeing it, if you're zooming really good there, it's 4. And you could actually zoom in on YouTube videos, you know. Did you know that? I don't know if you can zoom in on live YouTube videos though. I'll check and see if I can zoom in on this video here. Determine the median of the data given. You can zoom in, yeah. The median of the data given. What? The median of the data? Oh, well, you need to watch the frequency. So I have a few things we could do. How many students again? They asked you already. How much students? Oh, look, they say it up here. I don't know if I could see 35 students. Yeah, 35 students, right? So we have 35 students. So what are we going to do? If it have 35 students, how you find the median again? Median is Q2. The second quartile is the birth certificate name for median. Q2, quartile 2. And you find it by saying n plus 1 over 2, or half of n plus 1. And n is 35 plus 1 over 2. So that's 36 over 2. So that's 18th student. So it's the 18th student when you line them up in order. So we can go from top, or we can go from here. And we cross it out until we reach 18. 2 and 2 is 4, and 6 is 10, and 7 is 17. The 18th student is found in 4. So the median is 4 correct questions. Stop. It must be a 1 or 2 all you thinking I'm supposed to add up and dividend. 1 or 2 all you thinking I'm supposed to add up and dividend. Median mean middle. Mean, the average is when you add up and divide. Get it? So the median, I had to find the middle term, and the middle term is on the 18th student. However, because there were so much students here, it turned out that the middle term is actually quite here, instead of like you might think it's somewhere here, but it's actually here. Because most of these students, bright, most of them get between 3 or 4 or 5 correct. I'm calculating the mean number of correct questions obtained. See the comment mean now? So how do we find mean? There's 2 marks this time. How do we find mean? I need to go to a separate page for this, boy. Why all these statistics questions taking up all this page? Just give me a little page somewhere there. Maybe page 10, and maybe I can just sneak in this statistics class taking a right long, boy. Don't worry, we finishing now. Yes, so this is the formula. This is the special formula now. Now, wait till we had get there, we had get some kind of 4, 6, some kind of 6 something, 6, 12. You just fill back in this spot here. 6, 12. So it's like if I create a table and I want to write the table like this so you can see it. Number of correct questions. Then I have student number or number of students. Then I have Okay, let's do this first. So let's say I have 0. 2 students got 0. 2 students get 1. 6 students got 2. 7 students got 3. 12 students got 4. And 6 students got 5. So this is the frequency. And this is like your individual terms. Frequency and your individual terms. Is that good? No. This is the frequency and this is the individual, the number of questions, correct? So the frequency is the number of students. All right, we're ready now. So the next thing I need to do is get f of x, like how much students get each part correct. So 2 students got 0. So I can put 2 by 0 is 0. It have a reason for the madness. And 2 by 1 is 2. 6 by 2 is 12. 7 by 3 is 21. 4 12s are 48. 5 6s are 30. And then you add it up. So it's like you're working out all these students. Because remember, it is like 12 students get 4. So in all, their points will add up to 48. So again, the sum of all the points. So the sum, and that's the symbol there, of fx is equal to, somebody tell me how much is the sum of fx. You also need to know the sum of f. So the sum of f is just the sum of the frequency, which we already have been told is 35. So the sum of f is 35. The sum of fx is 113. So that's how you find the mean of grouped data like this. So the mean is the sum of fx, not the sum of f of x. F of x is function. Fx just meaning the frequency by the individual scores. Divided by the sum of f. 13 divided by 35. 113 divided by 35 is 3.29. 3.29 questions correct. So if I would add in if this is equal to 3 to the nearest question. So yeah, really, maybe they're not given that kind of 0.29 marks here. So I'll put this first and then say 3 to the nearest question. Right? Number 5. Well, all of these are number 5s, but let's do one more. I think we have it in me to do one more, boy. I feel it's just one more. How much people have in this life? 273. One more, people. Or you can do the 2 more. I try for the 1 more first and you see the energy for the 2 more. Oh gosh, a pie chart. Retract that. The table below shows the result of a survey that was conducted among 40 women to determine what their dream vacation destination is. Paris, London, Maui. Pronounce that word for a minute. Hawaii, Maui. Anybody from Hawaii know how to properly pronounce that? And other places. This is Hawaii, right? And then, okay, suppose the data collected is to be represented in the pie chart, determine the size of the angle that represents London. In London town. All right, so 40 women. London is equal to 16 women. So the angle, not a percentage, the angle has to be a fraction. 16 out of 40 multiplied by the full angles in a circle, 360. And how much I'll get with this? The trophy, the winning, the first place, the success belongs to the persons who are able to continue when the energy is low. When you are able to sacrifice now for a better future, that's when you're winning. That's when you're winning. 144. And now we need to find the others because we need to draw the whole graph and whatnot. So that's just London. Let me find Paris. Paris is 4 out of 40 multiplied by 360. Tell me like 36 now. I'm smelling at 360. 36 degrees. Maui is 12 out of 40. Multiply by 360. How much should I get for that one? And other is 8 out of 40. Multiply by 360. That's 72 degrees. 108 degrees. So we have them all. We collect them all. It's like Thanos and the rings. And now we can draw a graph. And the diagram below with radius shown represent the data collected by clearly. I kind of needed the overhead camera for this one, but oh, what we can do. So I wanted to show you all how I'm going to line up the angle on this. So maybe just set that camera I'm watching me right to the whole screen, and you can lift that camera up and just point it for a second. So but set it whole screen first. So yeah, I'll wait, stand by for action. Stand by for action. So we full screen, right? Right. So that's that camera, right? It have battery going to die. Oh, okay. Check the battery. Okay. So what I would do, you have more. Let's see. Task in progress. Do not the. I think it cut off. I think it cut off. This ain't working. All you have to use all your imagination. Just plug it back in. Just plug back in this one. Like this. So use your imagination. Use your imagination. I actually show you all how to do this on one of these statistics videos. So as I said, you could go and look it up on YouTube. Curve Spring and Statistics Pie Chart. You want to line up the baseline of the protractor with the given line. And these days when they're giving you to draw a pie chart, they starting you off with a line. Just bring back up the screen. They starting you off with a line ready. And normally we had an overhead camera here, but I thought I would not need it, but actually I do. So so you line it up, and then the center point of the protractor that goes on the center of the circle, and you mark off your angles. So the first angle is 144. So I can put here about this. So you notice because how the protractor was saying down like this on my thing, because of how big the protractor is, the angle here. So you actually need to come with a ruler now and join it up. Why isn't it chat if you know how to do this and join it up like that? So and then easy thing, well, some people struggle with it. So then you have the 36 to do. It's like about this. So I can see little random smudges come across on my screen because my finger touching it. And then 108. Who's the 108? Why? Maui. 108. He goes about there. So, and then 72 will be the remainders. So I feel like that was good. I feel like I could figure that out. And then we're going to put it in. We'll label up however you're feeling to label this thing. London, it's 144 degrees. This one as well, Paris. And this was 36 degrees. And this is on Maui. This is 108 degrees. And this is pie chart of favorite or desired destination, wherever I have a label day. And this is other. This is 72 degrees. And 1 degree is You don't need to put this. 1 degree is 360 divided by 40. Yeah. 4×36. 9. Distance. Hold on, I have this back to front. One person is that amount of degrees. Yeah, one person is 3. What's that? So I'm talking to myself. I'm talking to myself. One person is 360 divided by 40, which is 9 degrees. All right, so you don't really need to put the scale. I just was being a little extra here. Remember, I can't draw dots on this thing. So that's how we collect the marks in the pie chart. Yeah, so when I'm doing a new angle, I move to the new line. Easy. I've seen some people saying easy and some people saying their brain hurting. So we done the one more, or kita apa part B. Let me see if I draw anything. Doesn't look so. So therefore we shall do this. The incomplete table below shows the number of blue balls and red balls contained in 5 jars labeled A, B, C, D, and E. The makers of these questions is know what they're doing. So, all right, a red ball is chosen at random. Determine the probability that is taken from jar C. C, red, chosen at random. Hold on, I don't really know what's going on in this question. It had 200 of them in total. 200 blue balls, 200 red balls, and containing 5 jars. Okay. And we choose a red one by random. We actually pick a red one. Right. So if we choose a red one, the total number of red balls is 200. So the probability of picking from jar C has to be the number of desired outcomes over the total number of outcomes, which is 30 divided by, because it's jar C is just 30, right? Jar C, 30 out of 200 cross, so 320, is the correct answer. What percentage of blue balls is contained in jars B, C, and D? Well, so far, and when I say so far, I mean A and E, we have 28 plus 36. And 28 plus 36 is 64. So far, we have 64 of these fellas, 64 balls. So what percentage is missed out? So missing is 200 minus 64, which is 136. So percentage has to be, percentage missing would be 1, or in those jars, 136 divided by 200 multiplied by 100. Cross, 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 cross. How much y'all get for that? Oh, yes. 68% sounding real nice to me. 68% is good things. Looking at the values for the standard deviations in the table, compare the distribution of blue balls to the red balls. So I'll have to listen to me talk through this one. There's one more question. No, there's 2 more questions. One, I will ask you all when you finish this question if you want to do any more, or if you had enough and you want to just go and study for yourself. But let me know. So looking at the values for the standard deviation in the table above, compare the distribution of. So this is the kind of way. This is the way they're asking standard deviation over the last 6 years, 6 years. This is how they're asking standard deviation. No, 5 years. The new exam was in 2018. So how are they asking it to describe it? So you see, this one has the higher standard deviation. Here's the words, the keywords you want to use. You want to use the word spread, and you want to use the word deviate, spread or deviate, and you want to talk about further from the mean. Once you start to talk about them thing, you start to, hey, I feel like my pen dying for real this time. Once you start to talk about them thing, you're good to go. So here's what I mean. Let's just do a quick idea of standard deviation so you can collect this 1 mark when it comes in the exam, right? It will only take 3 minutes, so let's state me. If you go in a tongue, close up. If you go in a tongue, there you. And you walk in a tongue, right? And then you watch all the buildings in the tongue looking like this. This height, so like all the buildings in the tongue, like the streets there. All the buildings in the tongue looking like that height. What's the average height? The average height is this blue line here. Like the average height of the buildings in the tongue. And you can see most of them really close to the average. These is the two furthest away. And now if you decided to walk into another tongue, I'm gonna draw you, so there you here. And you walk into this tongue, and you see buildings looking like this. What's the average height of the buildings? Now the average height of the building might be the same as that tongue, but the idea is that they deviate way more. So the standard deviation of these buildings will be higher. So let's say the standard deviation of these buildings is like 7 stories. And this one is only like 1 story or half a story. It means if you watch the average height, and if you know the average height, the building is not far away from the average height. And these ones, the buildings spread or deviate. Why is in the chat if you understand what I'm saying? Further from the mean. That's all you need to know about standard deviation. And you need to use them keywords, them trigger words to make the examiner happy. Them spread and deviate, that thing. So how much people we have right now? 290. 290 of you all here. 297. All you want to go for our next question? I'm waiting for the comments to come up here. Have a little delay. First time catching one of you lives when it actually live. Love from Jamaica. Shout out your country. Hey, Jamaica in the house. So everybody's saying yes. Next question. Yeah, let me go. Yeah, yes. All right, so let me go. Next question. What's the time? I have a whole class to teach. All right, so next question is another cumulative frequency curve. Can you feel that? That's the immense joy I get every time I see one of these questions. So use the cumulative frequency curve, estimate the median. You have to estimate the median. So I need this curve to look a little bigger. Let me just see if I can just sneak it into the next page again, boy. Josie boy. That fella from yesterday, what's his name? What's his name again? Right? Go back to slide 1 day. Ghosty Pun here. Who was getting me talks about is Ghosty Pun in class? Ghosty Pun, if you're in class, go and sit down in the back. Go to the principal office. Ghosty Pun was saying Lakers going to beat Golden State. Did you watch the match, Ghosty Pun? I hope you felt the immense pain of a 30-point defeat. Dylan Brooks kind of talking. All right, so let's go to the new question. Page 14. So we need to determine the median, page 15. How do we get the median again? Page 15. I'm not trying to make this big. We're supposed to look at Q2 because the median code name in the streets is Q2. That's how they call him in the hood, Q2. And we're supposed to say Q2 is equal to n plus 1 over 2, or half of n plus 1. That's where Q2 is located, right? And we see now we have 120 of these people involved. How much? 120 vehicles involved, yeah. So therefore it's 120 plus 1 over 2. For all intents and purposes, is basically 60, right? 60.5. So we go in and look at 60, bring them across. They had to see them dotted lines, right? just a little smooth above 60, 60.5. And you touch there, and then you touch the road. I tell my students always remember to touch the road in these questions. You touch the road, and then you come back down. So it's on the 60.5th term or 60.5th value or 60.5th person, whatever you want to say. I'll see him. Go Stepan. Give me once that talks yesterday. Go Stepan, now you're quiet, so I'll show you inside here. You know? And then the speed is how much are you getting there? 42. I get 42. Zoom in on that another screen there. Remember, you can pinch your zoom. 42 kilometers per hour is the median. That's the median. Don't forget the units when you're writing these Q2 things and them kind of thing. Eh? Yeah, come out. It's really looking like a 42. The lower quartile, that is code for Q1. So this was Q2, Q1, and I just explained how we get these quartiles things. So you can look it up after this in my statistics. By the way, semi-interquartile range is Q3 minus Q1. Eh? So let me go ahead and find Q1 now. Q1 is the same thing. You see the 120. Just cracking my back. Divided by 4 this time, and you get 30.25 or something like that. Then you swing across, they touch the road, come down. This actually looking like a 36.5. So Q1 turned out to be 36.5 kilometers per hour. Same idea. I just kind of skip out some of the points. Q1 and Q3, same thing, 120. But you're using the other formula, 3/4 of n plus 1. And what you're going to get, you get 90.75 or something like that. And you just swing across the, hit that line full speed, bow, and then come down. And looking like a little, just now it coming to me, 44.5 kilometers per hour. Niceness. 300 people, hey, we make our next 300. So 44.5 kilometers. And now if you want the interquartile range, fondly known as IQR, you just say Q3 minus Q1. So that is 44.5 minus 36.5. Marissa, tell me what that is there. Okay, or some of these CD people in this chat. So will CXC release broad topics? If I had $1 million every time somebody asks me that. Cool, creaming, but no. No broad topics will be released. So check Q1, did I make a mistake with Q1? How much I get for Q1? I get 36.5. It looking like 37, nah, but I know why I see 36.5. So 8 kilometers per hour. Let's stop writing things just so now, boy. Put in the units now. Well, I need to actually again, so I need to see again for the put in the units, boy. So what we do everything. The number of vehicles whose estimate speed is. You see this question is incomplete. So let me just ignore it. That is something else to tell Nalini. I tell her for the last two is in question 4. So see if you can find it back and just show her something incomplete here. So what I'll do, the number of vehicles whose estimate speed is 35 kilometers per hour or less or more, right? That's the part missing out of that question. So you go 35, you hit the road, and then you come across here. Let me do it on the more zoomed in diagram. So you come from 35, you hit the road again. That's the Bennett's line I draw for the series, boy. Hit the road, bang, and you come across dotted lines. They're just keeping it straight for 22, 24, 26, 26. Remember, you're counting in 2s on this axis. So you get 26 students. So you see that number is 26. So if there was number of vehicles whose estimate speed is 35 kilometers or less, is 26. If it's 35 kilometers or more, you will say 120 minus the 26. So you get rid of the 26 who's slow and you read the more. Why is in the chat if you understand? Yeah, so they're not giving a topics by. You gotta study everything. Using the cumulative frequency curve above, complete the table. So I do this already, and you all can check out cumulative frequency curve on my channel to see like the ideas of how to build it from scratch. What you want to do is, could I just do this quickly? There's the probability. I'll skip the probability, but let me just see if I could squeeze this in quickly to say that I do everything now, boy. 20 to 30. So you see when it reached 20.5, it was on 4. You see now? 2, 4. So who's the next one? 30.5. I need to see where it was on 30.5. So when I go 30.5, it was on 4 less than 20, 16. So it was on 16. That don't mean to put 16 here. Come on, people. You had to take away what it had before. So you had to put 12 here. Because remember, you add in. So this and this makes 16. Let me show you again. I'm going to do 40.5. 40.5. Let me go back. 40.5. Run up that graph. 40.5. Hit the 40.5 looking like 44. And yeah, because remember, you're counting in 2. So there's 44. So let's go back to 16. So that don't mean to put 44 over here. And slide 16. You don't need to put 44 over there. You need to take away all them things from before too. So if I take away 44 minus 16, how much I'll get? 28. Now you just need to add up all of this, 26, 28, to make sure you get the same, the total number now of vehicles. So you can do it and double check. If you realize you're off by 1 or 2, you could just tweak one of the numbers so that it could be exact, right? It's hard for me to get say like I totally confident in my numbers because I'm using a digital thing here and I can see everything. So that's how you do cumulative frequency in reverse. Check my video to see how you do it forward. While you feel like you could do our next question 5, boy. I'll leave in all the probability one. We do things like that enough already. Another question 5. I feel it like we good day. What this next question 5 is about? Modal class, mean, same thing. Same FX. So you see now modal class talk there. What's the modal class? Let's see if I can do this. Take a screenshot and do it now and put the answers in the chat. Modal class, bring it up. Modal class. I'm not giving no hints. Modal mean most frequent. I'll just give a hint. Calculated estimate of the mean height. I do this already. This is the sum of fx over the sum of f. And researchers stated in finding that the median height is 164. And I just do this too. How do we prove if the median is correct? How do we prove if that median is correct? Give an answer, right? And then the next part on slide 18, we had to do slide 18 because it's kind of different to what we are accustomed to. This is like the deepest probabilities get into for CSEC Maths. So let me take a little dive on slide 18. Last one. This is the finals here. So I hope I'll take a screenshot of slide 17. Let me just go back to it. Take a screenshot of that and see if you can do this slide 17. Right? And let me go to slide 18 now. Okay, so complete the table by inserting the missing values. How are we figuring this out? Oh, it's at totals. Oh, it's at totals. There's a total line here. Not a total line there. So it's total on the left hand, total on the top. So if it has 72 here, this is like Sudoku. You're missing that number there. What could that number be, boy? It's so hard. It's so hard. All right, so 22 and 50. Oh, they give you a real clues with this, boy. What could that number possibly be? Class 34. 34. That number to be 34, boy. Right there. Yeah, 34. So when I subtract this from that, I get 34. If I subtract this from that, I get 34. What about this? What can the number be here? Well, I have these two. So I just need, and you're surely working, 34 minus 21, and you will get, come on, critical thinking skills. So after I get this one, I'll be able to figure out this one, then this one. Niceness. So I get 13 here. And this plus this, I use any chatter, this plus this subtracted from 48. So I want 48 minus 35. And that will give me my missing term there. I get the 3522 plus 13, which is 13 again. And then finally, I add these two together. 30. And you double check to make sure that all of these add up as well. They could have leave out more things. They could have leave out more things because it was kind of easy. They could have leave out a little more things to make it a little more challenging. An employee is selected at random. What is the probability that she has green eyes? That he or she has green eyes. So they want the total employees. So you use this number. Total number of employees, right? So the probability that they have green is the number of desired outcomes. I fed up right this boy. I'm writing this again. The number of desired outcomes over the total number of outcomes. And the number of desired is 13. Oh, no, 30. 30 people are green eyes. I say he or she. And it's at 120. So this is a quarter, 25%, 0.25. Probability can be expressed as a percentage, a fraction, or a decimal. One of the females is selected at random. So it's a female. And I would it's some kind of cringe these days, but you see, it's a female. Okay. So all right, how much ladies? 48. 48 females. What is the probability that she has brown eyes? So you already select the female. So it's out of 48 now. Why is in the chat if you understand? So it's not out of 120 now. You selected already, you already selected a female. And what's the probability that this female, given that you have already selected a female, has brown eyes? So this probability for brown has to be the 22 out of the 48, which is 11 out of 24, and we cooking it Ramco gas there. So that's a little walking statistics. Notice we just did some pie charts, we did a bar graph, we didn't really look at histograms, did we? No. So go and search Kerwin Springer, that's your homework, histograms, Kerwin Springer histograms on the channel, and watch out them histogram video, watch out the other statistics video. After we do every session, you could go and look up the individual topics on the channel and you'll see little snippets. Those of you all in my class, after we do the topic, you could go back in the whole class and watch over that whole class. You'll all have an extended version of it. So y'all could, and you'll have good type of notes, and then you'll have all the compilations and the assignments and the solutions. And you know, we treat all you nice in the classes, in the student tab. So run the ad day one time. Next week, Saturday, crash course. Those of you all in my class, you're in free. Those of you all who not in the class, sign up by WhatsApp in this number on the screen. 4724221. Remind me to change that number to the new number, right? But you could still use that number, 4724221. We have students from Jamaica signing up. We have students from Barbados. Of course, we always have the Trinidad and Guyana. Those are the two largest countries for the student help classes, right? But we actually have students from all over. We have had students from every single country in the Caribbean. We always have a clip from Grenada, from St. Lucia, from Antigua, some of the top students in Antigua, Grenada, and St. Lucia. Like when I say some of the top, I mean the top, the student who did the best in CXC for certain years. We got them from Antigua, most number of subjects, 15, 14. So the student hub is really the place to be. Love and blessings.